Hi everyone, good evening, welcome back. Hello everyone, how are you all? Welcome back my dear friends, welcome to PW NEET English and welcome to this amazing lecture in which we are going to complete most important and most repeated questions from physics. How are you all? Quickly let me know in the chat box if I am clearly audible and visible. Hello. Hi Divya, hi Neha, hello Dipti, Ananya. Good evening everyone. Good evening. How are you all? Hi Mohit. Hi Qureshi. I can just read your surname. Hi, I'm all good. I'm all fine. Excited for today's class. Good evening Muskan. Hi Faizan. Hi buddy. Hi Casper. Uh, Hi everyone. Hi. Welcome back. Let's start today's lecture. Let me again tell you in today's class we are going to solve most important questions, right? All right, let's start. Everything is cool. I am audible. Let me check again. Yes, I think everything is fine. Great. All right. Done. Let's start. So, please mind us Kerala students. Obviously. Let's begin. So, first question is from modern physics. We are going to first give our attention to modern physics part and then we are going to start different topics, right? Let's begin. This is the first question. I'm going to also give you poll. Let me read it for you. Monochromatic photons, each of energy 5 electron volt, are incident on a photosensitive plate of work function 2 electron volt. You have to find the answer. 60 seconds is your time. Let's begin. Please note, work function is 2 electron volt and energy of incident radiation is 5 electron volt, right? Is watching videos of top 100 JEE PYQs is good for now, or please give me a solution? Well, if you are solving JEE mains, then it is good. If you are solving anything above JEE mains, then I won't recommend it. Second, I have already solved lots of questions from JEE mains on this channel, so you can find my videos as well, right? Obviously, we are going to use Einstein's equation in this, dosto, है ना? Einstein's equation says that energy of incident radiation will be used in two things. One, to overcome the work function. Second, the energy will exist in the form of kinetic energy. And why do we write it as maximum kinetic energy? We write down maximum kinetic energy for a simple reason that in reality, the kinetic energy of electrons is basically, it falls in the range of a maximum value to 0. This is the answer, right? This is the answer, my dear friends. Please note that not all electrons have same kinetic energy, right? That's why we write it as maximum kinetic energy over here. So different electrons are going to have different energy depending on where those electrons are. So let's suppose you have got a metallic surface, a metal over here, somewhat like this, right? So it will depend that which electron is coming out. So different electrons are going to have different kinetic energy. Some electrons might also have zero kinetic energy. That is also possible, right? So the answer is going to be kinetic energy. The maximum kinetic energy will be, if I'm going to use this formula, that is E minus phi, that is energy of incident radiation minus work function. So energy of incident radiation was 5 electron volt minus 2 electron volt, that is 3 electron volt. So this will become 3 electron volt, right? So answer is going to be from 0 to 3 electron volt. From 0 to 3 electron volt, that means option A. Very good, great going, right? Clear? Moving on to the next one. Hopefully this is absolutely clear. Next question says, a certain metallic surface is illuminated with monochromatic light of wavelength lambda. So wavelength is lambda, alright. The stopping potential for photoelectric current for this light is 3V0. Please note that this is stopping potential, right? Next is, if the same surface is illuminated with the light of wavelength, 2 lambda, and the stopping potential is V0, that means stopping potential has decreased, the threshold wavelength for this surface of the photoelectric effect is. Let's start. 90 seconds. Let's begin. Quickly let me know in the chat box. First of all, they are saying that wavelength is lambda. Let's assume the threshold wavelength to be lambda naught, right? Let's assume threshold wavelength to be lambda naught. So we are going to write something like this, that Hc by lambda is equals to Hc by lambda naught plus stopping potential is 3V0. So this will become 3eV0, and then wavelength becomes 2 lambda. So Hc divided by 2 lambda is equals to, this will remain same, that is Hc divided by lambda naught, plus now the stopping potential has become V0. So this will become E times V0. It will become E times V0. Hopefully this is absolutely clear. See, I really don't want this E V0. So what I am going to do is, these are basic problems that mostly NTA ask. In JEE mains also you are going to see these types of problems. Let's multiply this equation with 3 just so that we can get 3 EV0 both sides, right? And if you are going to do this, my dear friends, you are going to get Hc by lambda is equals to Hc by lambda naught plus 3eV0, and this equation will become 3Hc by 2 lambda, this will become 3Hc by lambda naught, and this will become 3eV0. And now let's subtract these two equations. That's all you need to do. This will get cancelled out. We don't want our answer in terms of V0, and if you are going to cancel this, this will become, dosto, obviously I am going to change the sign. This will become 2Hc by lambda naught, and this will become 3 by 2 minus 1, 3 by 2 minus 1 is 1 by 2, that means Hc by 2 lambda, right? So Hc gets cancels out, lambda naught comes out as 4 lambda. So it should be 4 lambda. That is option number A. Clear? Quickly write down in the chat box. Dosto, be quick. Option A is absolutely correct. Right? Be quick. Very repeated type of a problem. Right? So that's what we are going to do in today's class. We are going to revise everything. Logic gate, we are going to revise logic gate. We are going to revise semiconductors. We are going to revise atoms. We are going to revise nuclei. After that, we are going to revise electrostatics. We are going to revise each and everything. So wait, right? Wait till the lecture ends. You are going to get each and everything. Very, very good. Some of you have thought the answer is 6 lambda. So please check, right? I think today we are not going to do gravitation, but certainly in some next class we will talk about it. This is a nice new type of a problem, but not difficult. Question says a plane electromagnetic wave is incident on a plane surface of area A normally and is perfectly reflected if the energy E strikes the surface in time t, then the average pressure 60 seconds. Let's start. Let me tell you what they are trying to say. They are basically saying that we have got, let's suppose we have got a surface like this, right? We have got a surface like this, and some electromagnetic wave is falling on this surface normally, my dear friends, something like this. Clear? On this normally, and you need to find out the average pressure. By the way, this pressure is nothing but, this is radiation pressure. This is nothing but, this is same as radiation pressure. Now the formula for radiation pressure is 2 times of intensity divided by speed of light. 2 times of intensity divided by speed of light. दोस्तों intensity can be written as power divided by area. So 2P divided by AC, right? Please remember this is radiation pressure. So 2P divided by AC, pressure can be, power can be written as, please remember this is pressure, this is power. Power can be written as energy divided by time. So this will become ACT. So 2E divided by ACT. This is going to be the correct answer. Option number C. Very good. Clear? These are warm-up questions. Don't worry. We are going to come to some nice problem related with this concept. For example, as let's try to solve this question. Let's try to solve this question. An astronaut tries to reach back to space station at a distance of 100 kilometer from himself by using his flashlight of 1000 watt as a propellant in space. Reflector of his flashlight is of area 0.5 meters square and total mass of astronaut and his gear is around 150 kg. The radiation pressure obtained from the flashlight is 60 seconds. Let's start. Come on, be quick. Be quick. Solve this question. An astronaut tries to reach back to the space station. Alright, and what he is using is, he is using a flashlight. Power is given as 1000 watt. Please remember, power is given as 1000 watt. Area is mentioned and mass is also given, but you find it out if you want to use it or not. Quick. Always my blessings are with you. Quickly solve this question and let me know the answer. Come on. Good. Very good. Although the formula for radiation pressure is 2I by C, but in this case we are going to change the formula for a simple reason that, understand one thing, the concept is that when photons actually fall on it, when photons fall on this, they actually they reflect back with the same velocity, है ना? So there is a change in momentum, correct? In this case there is change in momentum. Right now this is not what's happening. Please understand, I am explaining this concept to you. In our usual cases, like for example as in this one dosto, this is a normal incidence and then photons actually they rebound back, they rebound with the same speed. So there is change in momentum, and change in momentum is 2mv. This is the change in momentum. Right now this is not what's happening. In this case you have got a flashlight, and from that flashlight photons are coming. So we are going to not have this 2, instead we are going to say that only half of this radiation pressure will be used in our case. So that means this 2 will get cancelled out and answer will be intensity. Intensity is simply power divided by area. Power is 1000 watt divided by area is, my dear friends, 0.5, that is half. And then you have got C, that is 3 into 10 to the power 8. Hopefully everything is clear. If you are going to solve this, you guys can see this will get cancelled out, we will get 10 to the power minus 5 and you will get 2 divided by 3 into 10 to the power minus 5. Answer will be obviously, you have got pressure, so Newton per meter square, answer will be Newton per meter square. And if you are going to closely see, actually either you can write it down as 6.67 and increase the power, or this will become 0.67. So 0.67 into 10 to the power minus 5 is the correct answer. So option A is absolutely correct. Okay, just a second. Option A. No students participated. Okay, I think there's some problem in the poll. I'll get it checked. No issues. Let's come back and now you guys solve this question. Options are over here. These, please solve more and more questions like this, right? The photoelectric, you need to read the statements. You have got 5 statements and you have to select the option. I'm starting the timer, 60 seconds. Okay, again there's some issue. Okay, fine. Till then read the question. The photoelectric, 60 seconds. The photo current is proportional to the intensity of the photo current is proportional to the intensity of the incident radiation. Is that correct, my dear friends? You tell me, is that correct? I think so, right? Photo current does depends upon the intensity. More intensity means more number of photoelectrons can come out, right? More number of photoelectrons can come out. So this statement is correct. This statement is correct. Maximum kinetic energy with which photoelectrons are emitted depends upon the intensity. This is absolutely wrong. This is absolutely wrong, my dear friends. Maximum kinetic energy does not depend upon the intensity. Just now we have written maximum kinetic energy depends upon the incident radiation's energy. So this will be equals to energy minus work function, right? So this statement is incorrect. This statement is incorrect. Then maximum kinetic energy with which photoelectrons are emitted depends upon the frequency of the incident radiation. This is absolutely correct again. It does depends upon the frequency of the incident radiation. As you guys can see that kinetic energy, maximum kinetic energy can be further written as H multiplied by nu minus nu naught, where nu naught is the threshold frequency, right? So more frequency of the incident radiation, more kinetic energy. So statement 3 is absolutely correct. Statement 3 is absolutely correct. Then the emission of photoelectrons, require a minimum threshold intensity. Intensity has got to do nothing with the emission of electrons, right? The role of intensity will start after threshold frequency. No matter how much frequency you are going to throw on a particular metal, no electron is going to come out. Very basic thing, note it down. Intensity has got to do nothing with the emission of electron. Once the frequency of incident radiation is more than the threshold frequency, then you can talk about intensity, and then intensity, if you are going to increase intensity, that will increase photocurrent. Got it? So this statement is absolutely incorrect. Maximum kinetic energy of photoelectrons is independent of frequency. This is also incorrect. We have already discussed it. So I think there are only 2 correct statements, that are option A and option C. Now the most important point, please see, choose the correct answer. This is also very, very important. Don't do any mistake. They are saying to choose the correct answer, right? So that means only A and C. A and C, that means option B is correct. Oh, my bad. Sorry. A and C. My bad. Because of me, your one poll got wronged. Sorry. Answer A is correct. A and C. A and C. Moving on to the next one. Okay. Sorry for this. Let's solve this question. Be quick, dosto. Be quick. Correct. Very, very good. Let's, by mistake I selected B option. A surface of metal is illuminated with the different wavelength. Alright, so different wavelength. What are those wavelengths? 248 nanometer and 310 nanometer. Fine. The maximum speed of the photoelectrons corresponding to these wavelengths are V1 and V2. Doston, U1 and U2, the ratio is also given. The ratio is also given, 2:1 and HC is given. Even if they are not going to give you this now, we are going to always use 12400. Then if we are going to write it down in 00, then angstrom. If 1240, then nanometer. Work function. We need to find out work function. Times starts. Come on. Be quick. Be quick, my dear friends. Let's start. First of all, let's write down E1. E1 is going to be 1240 divided by 248. Divided by 248, right? So if I am going to multiply it by 5, will it work? Because 250 times 5 is 1250, है ना? So will this work, dosto? What do you say? Yes, 5. Yes, 5. This is 5 electron volt. And E2 is 1240 divided by 310. So multiplied by 4. 4 ones are 4, 4 threes are 12. So 4 electron volt. Alright. Now let's use these two values. First, 5 electron volt is equals to work function plus maximum kinetic energy, and that we are going to write it down as half m into u1 square, and then 4 is equals to work function plus maximum kinetic energy half mass of electron into u2 square, right? Next is going to be, when we are going to actually rewrite it, we are going to get half m u1 square is equals to 5 minus work function, and half m into u2 square is equals to 4 minus work function. And then let's take the ratio of these two things. Half can be cancelled out, mass can be cancelled out, and u1 upon u2 is, my dear friends, u1 upon u2 is 2 by 1. So 2 divided by 1 whole square is equals to 5 minus 5 whole divided by 4 minus 5. Clear? Now I am going to solve it over there only. Hopefully you guys can see. This will become 4 by 1. This will become 4 by 1. Let's multiply it. So this will become 16 minus 4 5 is equals to 5 minus 5. So this will become 3 5 and this will become 11. Answer is coming in decimals, fine, no problem. This will become 11 and that will become, so 5 will be 11 by 3. So some 3 point some. So 3.2 maybe, 3.2. No, 3.7. Quickly let me know the answer. 3.7. 3.7 is the correct answer. This is some 3.7. To be exact, maybe some 3.67, right? Clear? 3.7, that means option A. Moderate question, my dear friends. Please note, moderate question. Very good, Neha, Yash, Tejaswini, and everybody. Good. Clear? Moving on to the next one. If any student has any doubt, you can ask me in the chat box. I will go back to that question and explain it again. Okay? Clear? Always use tricks like this and then you can proceed with Einstein's equation. Moving ahead, my dear friends, let's solve one or two theoretical questions again. Which metal will be suitable? Quickly, let's start, 60 seconds. Which metal will be suitable for photoelectric cell using light of wavelength 4000 angstroms? The work function of sodium and copper are 2 electron volt and 4 electron volt. Come on, let's do it. Be quick. If any student has any doubt, do let me know. If they are saying that which metals will be suitable, that means you need to select a metal in which electron emission can take place with this wavelength, right? With this wavelength. Got it? So with this wavelength, electron emission should take place. Now we already know the work function. The first step should be, my dear friends, find out the energy of incident radiation. So you can also write it as 12,000 electron volt, right? Or you can write it down as 12,000. I don't have any problem. 12,000 electron volt divided by lambda, that is 4,000. Right, and this answer will be in electron volt, and this is going to become 3. That means energy of incident radiation is 3. So if you are going to talk about this, then you are going to say that no electron emission will take place. No electron emission, as energy is less than the work function for copper, and for this obviously energy of incident radiation is greater than the work function of sodium. So we must select sodium for this purpose. Easy peasy, right? Clear? No doubt. Option A is absolutely correct. Very good. Some of you have thought copper, right? And some of you have thought both also. So answer is very easy. Moving on to the next one. Next question is this. Photoelectric current in an experimental study of photoelectric effect is made 0, right? If you have any doubt, do let me know in the chat box, my dear friends. Photoelectric effect is made 0 by making anode negative with respect to the cathode. If potential is V0, then you have to select the correct option. Kinetic energy of the emitted photoelectron is equals to KeV0 for every emitted photoelectron. Kinetic energy is greater than EV, or maximum kinetic energy of emitted electron is EV0, or the sum of kinetic energies of emitted photoelectrons is this. This will actually help you to revise your entire chapter. Huh? Got it? We are going to revise entire chapter through these questions. Be quick. Are you sure? D is not correct. Somebody is also saying B. Hari Prasad. Hari, you are saying B. Varun, you are also saying B, bache. That means every electron has kinetic energy more than EV0. That's not correct. That is not correct. Chalo, let me explain this to you. Please see what they are saying. Dekho, let's suppose this is a target metal, right? This is a target metal, and my dear friends, over here we have got another electrode. Now what they are saying is that photoelectric current in an experiment fine effect is made 0 by making anode negative with respect to the cathode, right? So that means this was the target metal. Over from here energy falls on it. Let's say this energy is H into nu. Got it? And let's suppose, my dear friends, work function of this is, or threshold frequency is nu naught. That means the electrons which are going to come out, the maximum energy of this electron will be H nu minus nu naught. Now there is a way of writing kinetic energy, dosto. It is charge multiplied by potential, that is E multiplied by stopping potential. E multiplied by stopping potential, right? So we apply the stopping potential. Please note what I am trying to say. We apply the stopping potential to stop the electron having the maximum kinetic energy. By saying this, we basically are saying that if maximum kinetic energy electron is getting stopped, that means each and every electron will come at rest, right? So the answer is going to be definitely C. Maximum is going to be equals to EV naught. Answer is C, not B, not D. Answer is C. Well, many of you have thought that kinetic energy will be greater than EV. That's not possible. That's not possible, right? Clear? Got it, my dear friends? Quickly write down in the chat box. Sorted? Explanation is clear, so write down. Explanation is clear, crystal clear. Quickly write down in the chat box. Now I am moving on. Let's solve another question. This is a nice problem, okay? So pay attention. And then let's start. You have got stopping potential is plotted against 1 upon lambda, and you need to find out for two metals, you need to find out the correct option. 60 seconds. Let's start now. Be quick. Done and dusted. Very good. Good, good, good. Crystal clear. Very, very good. Explain photoelectric effect shortly. ठीक है. Amit, I'll explain it to you in short using this. ठीक है. I'll explain it. Your demand has been accepted. I'll explain photoelectric effect in short using this question. Come on. Let's start. Photoelectric effect basically says that first of all, please pay attention. Huh? If incident radiation has, let's suppose, energy h into nu or hc by lambda. Got it? It has got energy as hc by lambda. Done? Then photoelectric effect basically says, or to be precise, the Einstein's equation basically says that hc by lambda is actually equals to work function plus maximum kinetic energy. That means the energy of the incident radiation, will be used in two ways, will be used in two things: to overcome the work function, and the remaining energy will exist in the form of kinetic energy of electrons, something like this. Now let's suppose you want to find out the graph between stopping potential. They are saying stopping potential. So please note this, let me write down kinetic energy as maximum kinetic energy as hc by lambda minus phi, hc by lambda minus phi, hc by lambda minus phi, right? And mind you, please see what I am getting. I have got over here as E multiplied by stopping potential is equals to hc by lambda minus phi. And if you are going to allow me, I am going to now rewrite this equation as, everyone please see, Vs stopping potential is equals to hc divided by E times lambda minus phi divided by E. This is the equation that we are looking for. This is an equation of straight line equation. Kindly see, this is y equals to mx plus c. This is y. I'm sorry doston, this is actually lambda is in the denominator, of course, right? See, this is y, m, x is 1 upon lambda. Please see, x is 1 upon lambda. As you guys can see over here, x is 1 on x axis, you have got 1 upon lambda, and then minus phi by E. That means this is your, that's your y intercept. Got it? So if you want to actually draw the negative x axis also, something like this, and you are going to actually bring this down, then this is going to be the work function for your first metal. This is going to be, let's suppose this comes out to be 5, this unit comes out to be 5, this length comes out to be 5. So 5 electron volt is the work function of this. and that means that the work function of metal 2 will be somewhere over here. Can you please see negative y-intercept? You all can see negative y-intercept, right? So now the point is that slope of this equation is दोस्तों hc by e, which is constant. H is constant, C is constant, E is constant. So this thing is constant for any metal. It does not depend upon any metal, my dear friends. But this year they can also ask you about what about y-intercept. So you can say, sir, y-intercept will be different for metal 1, for metal 2, and which one will have greater y-intercept? Metal 2. I am talking about in magnitude. So metal 2 has got greater work function, definitely. Theta are same. So theta 1 and theta 2 are same for any two metals. So answer should be option C. Got it? Clear? Any doubt? Can you please write down crystal clear in the chat box? Metal 1 will be, we can't talk about anything like this, right? We don't know the work function of gold or cesium. By the way, gold 2 cannot be cesium, because I know that cesium has got the least work function. So second can't be cesium. Second has definitely, second has work function more than 1. Clear? Done. Very, very good. Option C is correct. Great here. Great. Very good. Very, very nice. Let me know in the chat box if you have any doubt. Crystal clear. Sir, मेरा message नहीं जा रहा. But I can see your message. I can read it. Crystal clear. Very good. Nice problem, right? So remember this. Remember the graph. This is given in NCERT. Remember this negative thing. Work function. Moving on to the next question. YDAC. What is the difference in option 2 and option D? Fine, I'll check. Option 2 and option D. Option B. Metal 1 and metal 2 are gold, and metal 1 is gold and 2 is, there is no difference. They are saying copper and cesium. That's what the difference is. Anyway, it is not correct option, so we should not worry about it. Let's start this one. Okay, they are saying in Young's double slit experiment, if the separation between the coherent sources is halved and the distance between the screen is doubled, very easy problem. Let's start. 60 seconds will be more than sufficient. They are saying what will happen to fringe width. Dosto, fringe width is one of the most repeated concepts in NEET exam. Most repeated concept. Fringe width. Formula of fringe width is lambda times capital D divided by small d. Lambda times capital D divided by small d. This is the concept. This is the formula, dosto. Right? And now they are saying you are not changing lambda. You are saying that the separation between the coherent sources is halved. This means that small d has been changed to d by 2. And then they are saying distance of the screen from the coherent source is doubled. That means capital D has been changed to 2d. It has been doubled. So your new beta will become, let's say beta dash, we are not changing lambda, so this will become 2d divided by d by 2. So this will become 4 lambda capital D divided by small d. 4 times. So 4 times of initial beta. 4 times of initial beta. That means option number B. Good here. Very good. Good. Let's move on to the next one. In diffraction, this is a nice problem. Mostly you guys know how to solve YDAC, but in diffraction you will have a doubt. I know it. That's why I have brought this problem. Let's solve this. In diffraction using single slit, a slit of width A is illuminated by a white light for red light 6500 angstrom. The first minima is obtained for theta equals to 30 degree. Then the value of A will be. Let's start. By that time I'll draw a diagram for you. They are saying something like this. Let's suppose this is the screen, and over here we have got one slit. Let's suppose something like this. We have got one slit, and we are having the first minima. We are having the first minima at 30 degree. At 30 degree. So let's suppose somewhere over here. -30 degree. First minima. Done. Right. Not maxima, minima. First minima. Now we know that for minima delta x, which is written as a sine theta, will be written as n into lambda. And by the way, a sine theta is, if you want me to draw, this is going to be the a sine theta. Got it? See this, and this. So this is going to be, this length is a sine theta. This length is your delta x. Done. This length is your delta x. So a sine theta is equals to n lambda. दोस्तों a sine theta is equals to a lambda, which means that we need to find out the value of a multiplied by sine 30 degree is equals to 1 into lambda. 1 into lambda. Right? What else, my dear friends? A sine theta is equals to a lambda. What else? That's it here. है ना? That's it. So a will be equals to lambda multiplied by 2, because this will become a into 1 by 2. A into 1 by 2 is equals to lambda, and a will be simply 2 times of this value. ठीक है? So this will become yeah, I think nothing else is given, na? Got it? Clear? I think options in this, let me check this unit. Hopefully unit is correctly mentioned in this. I will check once. They are talking about minima, right? हाँ सही है. Everything's correct, I believe. Everything is correct, right? Option is wrong. I don't think so. Let me check. So this is 660. This will actually become 113,000 and angstrom, that is 10 to the power minus 10, right? So they are giving me answers in, so this will become 1.3 into 10 to the power, or sorry, 13 into 10 to the power minus 7, or 1.3 into 10 to the power minus 6. Yeah, I am pretty sure we have not done anything wrong. I think that this should be 1.3 micrometer, है ना? So just because this is closest, I am going to select C. And hold on, let me tell you a very, very important point. Sometimes what happens is, you can also do this mistake. Sometimes you actually write something like this. Let me know that, sir, a theta is equals to lambda, and a multiplied by this will become pi by 6 equals to, this is actually 6500, right? So this is wrong. This is wrong because theta is not a small angle. Theta is not a small angle, so don't use this thing. I don't know if maybe that's how 1.24 came. Correct, got it. Our answer is absolutely correct here, no doubt about it. That's what the method is. So correct answer is option C. Maybe the solution of this or the option of option C might have come from here, but that's wrong. You cannot consider 30 degree as small angle. You are going to only consider small angles when angle is less than 10 degree. Moving on, dosto. No doubt about it, moving on. Let's see another question, right? Let's see another question. A Fraunhofer diffraction at a single slit of width d with incident light of wavelength 5500 angstrom, first minima. Now let's see if our concept is wrong, we'll get a wrong answer, else we'll get a right answer. You follow my concept. The first minima is observed at an angle of 30 degree. The first secondary maxima is observed. Let's quickly do it. Please remember one thing. Please remember one thing. The first minima is observed, right? So first minima condition will be, first minima condition is going to be, my dear friends, delta x path difference, that is a sine theta, and this is 30 degree, will be equals to n lambda. First minima is n lambda, my dear friends, n lambda, n lambda, n will be equals to 1, n will be equals to 1, right? So you are going to get a equals to 2 lambda. You are going to get 2 lambda. Right? Fine, let's keep it like this. Let's keep it like this. We don't have to solve it. Next is, they are talking about secondary, first secondary maxima, right? First secondary maxima. So for first secondary maxima, a sine theta is 3 lambda by 2, right? 3 lambda by 2. 3 lambda by 2. So let's write it as theta dash. So sine theta dash will be equals to 3 lambda divided by 2 into a, and instead of a, let's write it down as 2 lambda. Lambda gets cancels out. Theta dash comes out to be sine inverse 3 by 4. Sine inverse 3 by 4. Option C. Quickly let me know in the chat box if you have any doubt, dosto. Be quick. Any doubt? My dear friends, let me know. Our answer is absolutely correct for the last one. Don't worry. Be quick. Any more doubt? Write down crystal clear in the chat box if everything's sorted. Option C is absolutely correct. Good year, very nice, very nice, no doubt, great, clear. So remember the formula, this is for minima, this formula is for minima n lambda. The general formula for this is 2n plus 1 lambda by 2, 2n plus 1 lambda by 2, this is for maxima, right? Obviously we interchange the formula of YDAC, there is a reason to it, but right now you can simply remember this. Moving on to the next question of Young's double slit experiment, right? One of the most repeated concepts in NEET exam. YDAC is first performed in air, then in medium. Other than air, it is found that 8th bright fringe in the medium lies where 5th dark fringe lies in air. The refractive index of the medium nearly is, let's start. Please understand what they are saying. They are saying that then in the medium in air, okay fine, for the air one, 8th bright fringe coincides with the 5th dark fringe in air. Dark fringe is in air, by the way. Dark fringe is in air and bright fringe is in some another medium. We don't know what that is. Poll has started, bache. Poll has started. Let's start. Options are very close, by the way. 1.59, 1.69, 1.78, 1.25. Very close. Like 1.59 and 1.69 to very close. Right? Let's start. So it is found that 8th bright fringe in the medium, got it. So 8th bright fringe in the medium will be written by something like this, dosto. Basically the position is written by something like this. YB is written as n lambda capital D by small d, right? N lambda capital D by small d. So 8th, let's write it as, see I am just writing it in one way, lambda divided by mu. Dekho, kindly see, if in air wavelength is lambda, if let's suppose in air wavelength is lambda and we have got another medium whose refractive index is mu, then this wavelength will become lambda divided by mu. You must know this. Got it, dosto? So instead of lambda dash, I should have written it as lambda dash, right? Lambda dash. This is for bright, but I am writing it as lambda by mu. And other than lambda, nothing is getting changed. Huh? Capital D and small d are not going to change in another medium, by the way. So lambda divided by mu, capital D divided by small d is equals to this coincides. That means it happens to be at the same point as the 5th dark fringe. So 5th dark fringe is again 2n plus 1 lambda by 2, right? So for dark fringe 2n plus 1 lambda capital D by 2d, right? So hopefully everything is clear. So you are going to n equals to 0, so you are going to write it down as lambda capital D divided by 2 into d. Please solve and I'll tell you the answer and let me know if you have any doubt. Acha, 5th na, I'm sorry. Haan, so everything's correct na, just a second. This is actually 5th year, sorry. So why I've just a second. Let's use a negative wala sign. I have taken it as n as 0, sorry. So this will become 2 into 5 minus 1 lambda capital D divided by 2d. So d gets cancels out, lambda d gets cancels out, something like this, right? And you have got 8 divided by mu equals to, and you have got this becomes 9 and this becomes 2. So mu comes out to be 16 divided by 9. So obviously this will be 1 point something, but what that is going to be, I'll tell you. That's 1.7 some hai na, 1.78, 1.78. Everybody is getting C answer. Quickly write down in the chat box. Be quick. Everybody is getting C. Be quick. This is for dark. This is for dark fringe. This is for bright fringe. If medium is different, lambda will become lambda by mu. Equate them, solve them, you will get your answer. Clear? Any more doubt, my dear friends? So C is the correct answer. Very, very good. Nice. Let's move on to the next question. Great. Write down crystal clear in the chat box. Be quick. Moving on to the next question. This is, sorry, this got repeated. Exactly same problem. Moving on to the next very, very repeated problem. That is polarization. Polarization and Malus law. Malus law. Unpolarized light falls on two polarizing sheets placed one on top of the other. What must be the angle between the characteristic directions of the sheets if the intensity of the final transmitted light is 1/3 the maximum intensity of the first transmitted beam? Let's start. Be quick. You have got a situation like this. First, you have got a polarizer over here, right? You have got a polarizer over here. Right? This is the pass axis. Let's suppose intensity was I. Now it becomes I naught by 2. This is very important. Why? Because initially it was unpolarized. Initially it was unpolarized light, my dear friends. So this was unpolarized. So because of first polarization, intensity drops down to half. Then you have got another polarizer over here. Then you have got another polarizer over here, and let's suppose the axis makes an angle of theta degree. So the net intensity will be written by this intensity, that is I naught by 2 cos square theta. Now quickly solve this question, my dear friends. Be quick. Be really quick. Cos square theta. Solve and find me the answer. You know what cos 55 degree is? How do you know? 35 is not known, 75 is not known, 15 is not known. So how are you going to do? How are you going to do? First of all, hopefully this thing is absolutely clear. Now they are saying, dosto, they are saying that if the final intensity, final transmitted light is 1/3 of the maximum intensity of the first transmitted beam. This is the first transmitted beam. This is the first transmitted beam. First transmitted beam. That means I net will become 1/3 of first transmitted beam is equals to I naught by 2 cos square theta. दोस्तों I naught by 2 and I naught by 2 will get cancelled out. Cos square theta will be equals to 1 by 3. That means theta will be equals to cos inverse 1 by root 3. दोस्तों 1 by root 3, please understand, cos inverse 1 by root 2 is 45 degree. Is 45 degree. Right? And now this value is decreasing. By the way, please understand 1 by root 3 is obviously smaller than 1 by root 2. Yeah, if denominator is big, whole number will be small, right? So if this number is small, then angle will be more, because cos is a decreasing function. Cos is a decreasing function. Cos comes like this, right? So let's suppose this is 45 degree. So that means whatever this angle is 1 upon root 3, it's going to be somewhere over here because its number is less, hai na? Got it? It's going to be more than 45 degree. It's going to be more than 45 degree, and please note that then you have got 1 by 2 also. 1 by 2 happens to be at 60 degree. And 1 by 2 is smaller than 1 by root 3. 1 by 2 is greater than 1 by root 3. 1 by 2 basically means this, and 1 by root 3 basically means 1 by 1.7. That means 1 by root 3 is smaller than 1 by 2. That means this angle will be between 45 degree and 60 degree. And the answer is going to be 55 degree. If you have any doubt, do let me know in the chat box. I'll again explain the cos wala thing. Answer is 55 degree. Clear? Minimum would be 2n minus 1 lambda by 2. I have used that formula only, bachche. Varun, right? Varun, I have used that formula only. Clear? That's what I am trying to say. 1 by 2 is more. 1 by 2 is more, na? Got it? 1 by 2 is more. Let me write it something like this, dosto. This is cos, right? Let's say this is 1 by 2. This is 1 by 2, right? Now I am saying 1 by root 3. What I am saying is, if you are going to talk about 1 by root 3, is there any trouble here? 75 is not the correct answer, na? 55 is the correct answer, right? 55 is the correct answer. Yes, correct. 1 by root 3 is 1 upon 1.7, है ना? So this number is more, sorry, this number is greater than 1 by 2. This number is greater than 1 by 2. That means, sorry, I think I might have used the correct concept. It will be somewhere over here. It will be somewhere over here, right? It will be somewhere over here. So this angle was 60 degree. This angle was 60 degree. Correct? So this angle will be less than 60 degree. That's what I wanted to say. This angle will be less than 60 degree. Correct? And then, so we were talking about 1 by 2, which comes at 60 degree. Then you have got 1 by root 2, which is nothing but 1 upon 1.414. This angle comes at 45 degree, right? And obviously this is again greater than, and then you have got 1 by root 3, which is 1 divided by 1.7 something, right? So 1 divided by 1.7 and 1 divided by 1.41 and 1 divided by 2. So definitely this is 2, so this is least, then this is greater than 1 by 2, and then this is greatest. So 45 degree and 60 degree are extreme, so this will be in between 45 degree and 60, that is 55 degree. Got it? Now everything's clear. Quickly write down in the chat box if now everything is sorted. Done? Clear? Very, very nice problem. I have explained it to you again. Sorted? Doston, this is at 60 degree, this is at 45 degree. 1 divided by 1.7 is in between of 1 divided by 1.414 and 1 divided by 2. So that means the answer will be between 45 degree and 60 degree. Chalo, moving on. A very nice question. Mark it for your revision. Moving on to the next question. If you will write down crystal clear, that will motivate me. Moving on to the next one. A double slit interference experiment is carried out with monochromatic light and interference fringes. Alright, fringes are observed. If now monochromatic light, this is where question starts from. If now monochromatic light is replaced by white light, what change is expected in interference pattern? 45 seconds, your time starts now. Your time starts now, dosto. Be quick. Your time starts now. Quick answer. I want answer in the chat box. Also let me know last question is all sorted na. Sir फिर से बताओ पहले वाला. Dosto, what's happen over here is that if you have got a, let's suppose this is screen. Over here we have got two slits, right? This is where the central maxima will take place. Please understand, huh? See what happens is that at the central maxima, na, the path difference at the central maxima, path difference is 0 for all wavelength. For all wavelength. Delta x is 0 for all wavelength, right? So that's why at the central point we will have a bright, central maxima will be a bright spot, bright white spot. Got it? All the waves will actually come and there will be a constructive interference at the central maxima point. Now what will happen is, as you are going to move in this direction, the point is that y for bright fringe, we are going to write it something like this: n lambda capital D divided by small d, right? Now let's talk about first bright fringe. Now this basically means that y depends directly on lambda. Well, capital D and small d is same, and different color of light have different wavelength. So the light which has got maximum wavelength will be at somewhere over here, that is red, and the nearest will be violet. So they will spread out. So answer will be a few colored fringes are observed on either side of central right fringe. D is correct. D is correct. And the first bright fringe, dosto, the first bright fringe which will be of which color? Let me ask it again. The first bright fringe will be of which color? Violet, not red, violet, right? Because wavelength is minimum for violet, so Y will be minimum for violet. Got it? Moving on to the next question. Next problem. Let's solve this. In a double slit experiment, the distance between the slits is 5 millimeter. Small d is 5 millimeter, capital D is 1 meter. Two separate interference pattern can be seen on the screen when one light of 480 nanometer is used and another of 600 nanometer. The separation on the screen between the third order of bright fringe, dosto. Third order of bright fringe, that means what they are asking is, they are talking about Y3 1 minus Y3 2. That's what they are asking. Third order of maxima basically means 3 lambda 1 capital D by small d minus 3 lambda 2 capital D by small d, which means that I can take out 3 capital D was 1 meter, small d was 5 millimeter, and lambda 1 minus lambda 2. So lambda 1 is 600 minus 480 nanometer. Nanometer is 10 to the power minus 9. Nanometer is 10 to the power minus 9, mind you. Answer will be, dosto, answer will be, I can write down this thing as, let me write down 1 0 over here and 10 to the power 2. This will become 6. So finally answer will become 6 into 10 to the power 2 multiplied by, this will become, dosto, 120 multiplied by 10 to the power minus 9. So 6 times 12 is, I think answer we are going to get 7 2, and then you have got 3 zeros. This will become 10 to the power minus 6. So this will become 0.072 millimeter. 0.072 millimeter. B option is correct. B option is correct. Very good. Clear. Nice. Done. Everything's clear, dosto. Any doubt? Can we move on to the next one? They wanted us to find out the separation on the screen between the third order of bright fringes for both of the wavelength, right? So simply write down Y3 from first and minus Y3 from second. And Y3 is simply formula is 3 times of lambda capital D by small d. Alright. Chalo. Let's move on to the next one now. In Young's double slit experiment, the wavelength of red light is, we know it is 780 nanometer, 7.8 into 10 to the power minus 1 centimeter they are saying, and that of blue light is this. The value of n for which n plus 1th blue bright band coincides with the nth bright band. Let's start. 45 seconds. Chalo, try to do it. They are saying that the value of n for which n plus 1th blue bright band coincides with nth bright band, red band. Quickly solve this and find me the answer. Come on. Be quick. Don't do any mistake, bhai. Lots of you are saying C, some of you are saying B. For bright, normally the formula is n lambda capital D by small d, right, for bright fringe. I am talking about for constructive interference. So now for that one we are going to write n plus 1 lambda 1 capital D divided by small d is equals to n2, and for n2 we are going to write n times lambda 2 capital D divided by small d. So d gets cancels out, capital D gets cancels out, and when we are going to put the values, dosto, I think now you guys can solve it. This will become, hopefully this gets cancels out here by any way. Let's see, n plus 1 is equals to n and lambda 2. By the way, n is for red, n is for red. So lambda 2 is for red. Red is 7.8 into 10 to the power minus 5 centimeter divided by lambda 1, and lambda 1 is 5.2 multiplied by 10 to the power minus 5 and centimeter. This will get cancelled out. Point will get cancelled out. You can easily find out the answer. N will come out as 2. Solve it. You will get your answer as n equals to 2. N equals to 2. B answer is correct. Some of you have said C. Correct answer is B. Alright. Quickly let me know in the chat box why DSC. One theoretical question. Physical property shared by both radio waves and sound waves. 45 seconds. Both can be polarized, both can be reflected, both can be diffracted. Thank you, Guru Baran. Thank you, Guru. Chalo, come on, quickly solve this question. Physical property shared by radio waves and sound waves. That means electromagnetic waves and sound waves. Both can be polarized, both can be reflected, and both can be diffracted. Thank you, Ankita, thank you. Somebody is saying that sir's biceps are very distracting. Okay. Thank you. So both can be diffracted, absolutely wrong. They cannot be, both cannot be polarized. Sound waves cannot get polarized. Okay? Polarization is a phenomena which is exhibited by electromagnetic waves. Reason is that basically electromagnetic waves oscillate, the electric field and magnetic field oscillate in all possible directions, right? So that is not the case in sound waves. Sound waves oscillate in the direction of motion. So there is no point of talking about polarization and unpolarized waves in as far as sound waves are concerned, right? Whereas they can get reflected, we talk about reflection, we talk about incidence of sound waves, right? And second is they can be also diffracted. So diffraction is also possible. This is possible, reflection is possible, but polarization is not possible. So 2 and 3 are going to be the correct option. Option C. Very good. Clear. Done. Thank you, Mahira. Thank you. Let's continue. Chalo. Now let's talk about some of the atoms question also. Some of atoms problem also. Thank you, Mahira. Thank you. And thank you, Shahbaz. Thank you, Shahbaz. Thank you so much. Chalo, let's move on. For the shortest wavelength in the Paschen series, we don't talk a lot about Paschen series, doston. Let's talk about it. Paschen series of spectral lines. I'm starting the time, 60 seconds. 60 seconds. Let's start. Paschen. Lyman-Balmer Paschen. Lyman-Balmer Paschen. That means for Paschen, n final is going to be 2. N final is going to be 3. N final is going to be 3 for Paschen, right? And I have told you this many times, just hear me out. Just hear me out. Whenever they are going to talk about shortest, right? Whenever they are going to talk about shortest, please remember, note it down that it will come from the nearest shell, right? Or nearest state. Let me call it as nearest state. Why so? Let me tell you. Dosto, if an electron comes from the nearest state, that means let's suppose Ni is equals to 4. This means that the energy difference is going to be minimum. Please understand, energy is written as H times nu or hc by lambda. Sorry, they are talking about shortest here. That means this will come from farthest. This will come from farthest state. Please see, idea is that if delta is maximum, then lambda will be minimum. Got it? If delta E is maximum, then lambda is minimum. That means this will come from infinity, not from infinity. This will come from infinity. For shortest infinity, for longest wavelength. For longest wavelength, note it down. For longest wavelength. For longest wavelength, it will transition back from nearest excited state. So if delta E is maximum, that means frequency will be maximum, that means lambda will be minimum. Got it? So now let's quickly do it. So for this is going to be only one option is there. This is 3. This is, so answer A is correct. Got it, my dear friends? This is also infinity, by the way, but this is for Lyman. This is for Lyman, dosto. This is for longest Lyman wavelength, right? This is nothing. ठीक है, got it? If let's suppose n1 is equals to 1 and n2 is equals to 2, this is shortest Lyman. Clear? Everything is clear na? Done? This is longest Lyman, yeah, correct. Clear? Doubt is sorted? Really are more than 50 marks guaranteed. More than 50 marks guaranteed. You guys can see from the start of the session. Kanishka, yes, bachche. We have completed photoelectric effect, the dual nature of radiation and matter. 3 questions are confirmed from there, 2 from photoelectric and 1 from de Broglie. Then we have talked about YDAC and diffraction and polarization. YDAC, diffraction, polarization, definitely 2 questions confirmed. Till now 5 questions confirmed. 5 multiplied by 4, 20 marks is confirmed. Now we are talking about atoms. In atoms we are talking about Bohr model and this is energy transition. 1 question is confirmed. Myra, samajh nahi aaya, I'll repeat it again. Don't worry, I'll repeat it again. ठीक है? This is again 1. So till now 6 questions are confirmed. 6 times 4 is 24. Till the end of the session, 50 marks will get confirmed. Answer is option A. Very good. Simple thing, Mahira. If you want to find out longest wavelength, nearest state, electron will come from nearest state. Nearest state means energy minimum, frequency minimum, lambda maximum. Got it, bache? If you are going to talk about shortest wavelength, then farthest state, energy maximum, frequency maximum, lambda minimum. Got it, Mahira? Now moving on to the next question. Now everything's clear, na? An electron makes a transition from n equals to 4 to n equals to 2. N equals to 2 matlab means Balmer series. The wave number basically means, my dear friends, 1 upon lambda, right? Let's start. 60 seconds. 1 upon lambda is known as wave number. All right. 1 upon lambda is known as wave number, and mind you, 1 upon lambda is written as Rydberg's constant, 1 upon n final square minus 1 upon n initial square. Remember it like this, you will never forget. Remember it like this, you will never forget. 1 upon lambda will be equals to r multiplied by, finally it is reaching to 2, that means square of 2, minus it was coming from 4, that means square of 4. This means that this will become r 1 upon 4 minus 1 upon 16. This, let's multiply 4 over here, 4 over here. 1 upon lambda will come out to be 4 minus 1 is 3, 3r by 16. This is your answer. 3r by 16, option C is the correct answer. Clear? सर मैं पावर बैच का स्टूडेंट, सर मैं पावर बैच यकीन का स्टूडेंट हूँ. शाहबाज भाई वेलकम वेलकम. All right. C is the correct answer according to me. Poll by stop. Yeah, good. Moving on to the next one. Very basic, but please solve questions like this. Definitely you will get 1 or 2 questions from here. The magnitude of energy. Okay, let's, sir, if concept is not strong, but alone seeing this video, 50 marks is guaranteed, sir. Well, I can help as much as possible. Okay. But if your concepts are not strong, then I can't give you guarantee. Okay, else you will come to my home, you know my address, nahi na, then I can give you guarantee. Chalo, jokes apart, let's solve these questions. Definitely these are going to help you. If the magnitude of energy of the electron in nth Bohr orbit is En and Jn is its angular momentum, then nice. Let's start. By the way, En is written as En, as far as I can remember, it is z square divided by n square. We are not going to talk about z. That means this is equation number 1. I use box for equations. So I have boxed it. And then angular momentum. My dear friends, angular momentum is mvr. That's what angular momentum is, right? Jn. And by the way, R depends upon R naught n square by z, and V depends upon z by n, right? So Jn depends upon hopefully everything is correct here, right? So this will depend upon, instead of R I can write down n square, instead of V I can write down n. So this depends upon, it directly depends upon n, right? So yeah, correct. Is there any trouble kya? Is there any mistake? I can't find any mistake. अरे यार sorry, just a second. हाँ तो वैसे भी I could have said NH upon 2 pi also, no problem. That means N is directly proportional to Z. So हाँ तो D should be the correct answer ना. D should be the correct answer, right? D should be the correct answer, because this is, I could have also simply said that Jn is equals to NH upon 2 pi. I am sorry, I could have simply used this also, but no problem. No problem. Sorry, but I'll recommend you to use this. Okay, so this will become 1 upon, instead of n I can write down j square. So here I believe D should be the correct answer, right? No doubt about it. Good, very good. Sorry for this, है ना? Obviously, when they are talking about MVR, I could have simply said NH upon 2 pi, but no problem. Moving on to the next question. This question, again, one question from dual nature, but let's solve it. Let's be a little quick, huh? In this one, let's be quick. They have got work functions of cesium, potassium, sodium. These are, देखो, cesium has got the minimum work function, huh? Please remember it. So 2.14, 2.30, 2.75, if the incident radiation has energy 2.20, then work function should be less than this. Which of the photosensitive may emit? So only cesium. Only cesium will emit. No doubt about it. Only cesium will emit. D, not C here. Sodium will not emit, na? Only 2.14 is less than 2.20, right? I have not given this in poll because I think this is repetitive. Chalo. Moving on to the next question. For next question, I will give you poll. No, don't worry. Poll starting now. Read it quickly. Huh? Bohr's model is applicable only for hydrogenic atoms. I think this is true. Correct. Correct. It cannot be extended to even 2 electron atoms such as helium. This is also correct, but not a correct explanation. Reason is not a correct explanation, right? It makes no sense if we are going to club the two statements together, right? So answer is option B. By why correct statement? Yeah, you guys always mess in this one. Is reason is a correct explanation. I mean, why it cannot be extended to even 2 electron atoms such as helium. I don't think so. It's a correct explanation. Why it's a correct explanation? It's not explaining why. I mean, it's not explaining ki why. I mean, why it is only valid for hydrogenic atoms, right? The correct reason could be, according to me, the correct reason could be that because it is applicable for only single electron system. It is not even valid for helium is a statement in itself. It's a statement in itself, right? That's absolutely valid. But it's not explaining why it is only valid for hydrogenic atoms. The reason could be that Bohr model is not for complex electronics model, right? That could be one of the reason according to me. But yeah, there is a slight doubt, but I think reason is not a correct explanation, though both of the statements are correct. Clear? Chalo. More questions on assertion and reason, so pay attention. If you have any doubt, you can argue with me, no problem with that. You can discuss it with me. Assertion says in a photoelectric experiment, if the frequency of the incident light is increased while maintaining, I'm starting the timer. They are saying if the frequency of the incident light is increased while maintaining constant total intensity, the saturation photocurrent increases. Wow. And the reason is that saturation photoelectric current is directly proportional to the number of photons incident on the photosensitive surface per unit time. This is easy. Why? Because assertion is false. Assertion is false. If the frequency of the is increased, if frequency will increase, kinetic energy will increase. Maintaining a constant, this is absolutely incorrect. Incorrect. Correct thing will be to say that increasing the frequency will increase the kinetic energy, but current will remain constant because intensity is constant, right? Then they are saying that for the saturation photoelectric current is directly proportional to the intensity, to the number of photons incident on photosensitive material. This means that current is directly proportional to intensity. That's absolutely fine. So second statement is correct. That means reason is true but assertion is false. So B is easy. This one was pretty easy, right? Pretty easy. Moving on, next question. Which of the following relations is correct between time period and number of orbits while an electron is revolving in an orbit? Chalo, let's start. By the way, for time period, we have got 2 pi Rn divided by Vn. Just now I have discussed Vn and Rn for you. दोस्तों Rn depends directly on n square and Vn depends upon 1 upon n, right? If you are going to combine these, time depends upon Rn, that means n square, and 1 upon Vn, that means 1 upon n, which means that time depends directly on n cube. Directly on n cube. Clear? Done? Be quick, my dear friends. C is the correct answer. C is the correct answer. C is the correct answer. Great. Great. I can't see the chat. I can't see the chat. Just a second. Let me ask someone. Just a second. Don't go anywhere. You solve the next question. You solve the next question. I can't see the chat. Yeah. The energy levels of a certain atom, everything's going good, right? The energy levels of a certain atom for first, second and third levels are this. Fine. See what they are saying. For first level it's E. It's E. Then it's 4E by 4, 4E by 3, and then it's 2E. So first it's E, then it's 4E by 3, and then it's 2E. Timer on, 60 seconds. Let's start. A photon of wavelength lambda, is from 3 to 1. From 3 to 1 and wavelength is lambda. Wavelength is lambda. That means energy is hc by lambda. Energy is दोस्तों hc by lambda. I can also write it down. hc by lambda will be actually equals to 2e minus e. 2e minus e, that is E. And then they are saying what will be the wavelength of emission from 2 to E, from this to this. So let's suppose this is E dash. So this will be 4e by 3 minus E is equals to hc by lambda dash. This will become 3, this will become 3, this will become E by 3, and this will become hc by lambda dash. Instead of E, I can write it down as hc by lambda, right? 2e minus E is E. That means instead of E, I can write down hc by lambda. I have got already 3 over here. This is hc by lambda dash. hc cancels out. Lambda dash equals to 3 lambda. Lambda dash equals to 3 lambda, dosto. Lambda dash is equals to 3 lambda. Clear? Option number B. Option number B in the chat box. Done? Chalo. Option number B. Very good. Nice problem. Right? You can expect questions like these. Moving on to the next one. Quickly write down in the chat box if everything's clear till now. Be quick. B is absolutely correct. Always remember, whenever an electron transitions from an excited state to any other state, it loses energy in form of, it basically gives off photons, and those photons have energy which can be written as hc by lambda. Lambda will be wavelength of those photons, and energy can be also written in one more way. Final initial energy minus final energy, not final minus initial, because please remember, excited states have more energy. Got it? Excited states have more energy. Moving on. This is a nice problem. Let's start. I'll read it for you. Hydrogen, deuterium and a single ionized helium and a doubly ionized lithium all have one electron around the nucleus. Consider an electron transition from 2 to 1 if the wavelength of emitted radiations are lambda 1, lambda 2, lambda 3, lambda 4 respectively. Then approximately which of the following is correct? Let's start. Be quick. they all transitions from 2 to 1. They all transitions from N2 to N1, right? They all transitions from N2 to N1. Be quick. Come on. Time's up. See, this is a nice problem. Pay attention. Huh? The point is, if you want to write down lambda for anything, see, the general formula goes something like this. 1 upon wavelength is equals to R into Z square 1 upon N final, and that is, in this case, that's 1 minus 1 upon square of 2. So this is same in all three or in all four. This is same, correct? Right, bache? This is same. This means that lambda is, or I can say 1 upon lambda is directly proportional to Z square. Understand these concepts, huh? 1 upon lambda is directly proportional to Z square. This means that I can say that lambda multiplied by Z square is constant. Lambda multiplied by Z square is constant. And if this is the case, it means that now I am going to use this concept and I am going to say this means that lambda 1 multiplied by hydrogen Z is 1. So square of 1 is equals to lambda 2 for deuterium, and Z is still 1. Then lambda 3 and Z is 2, so square of 2, and lambda 4 and Z is 3, that means square of 3. That means you are going to get lambda 1 is equals to lambda 2 is equals to 4 lambda 3 is equals to 9 lambda 4. This is how simple this is. So lambda 1 is equals to lambda 2 is equals to 4 lambda 3 is equals to 9 lambda 4. Option C is absolutely correct. Option C is absolutely correct. Let me know in the chat box if you have any doubt. Many of you have thought option B also. If you have any problem, you can ask me. If not, then write down in the chat box clear. Sorted? This formula is all clear. This is same for all four atoms, right? So lambda is inversely proportional to Z square. R is constant. This is constant for everybody else. That means lambda into Z square is constant. That means this thing. Clear? Can I move on to the next question now? Sorted? Be quick here. Answer, reply. Moving on. Next question is related with de Broglie, है ना? De Broglie. That's what I have said, that we don't think that we have completed dual nature. Right? Let's complete de Broglie now. An electron of mass m and kinetic energy k. If a photon has a wavelength equal to the de Broglie wavelength of this electron, then the energy E of the photon is given by. Chalo. Quickly, let's do it. Be quick. Next question in front of you. Very good, Henry. Very good. They are saying we have got an electron mass m and kinetic energy k, right? So its de Broglie wavelength will be given by h divided by momentum, and momentum will be given by 2m into kinetic energy k. Then they are saying if a photon has wavelength equal to de Broglie wavelength, photon wavelength is given by, and they are also saying that the energy E of the photon is given by. So E will be written as hc by lambda of photon. And now they are saying lambda of photon is actually equals to lambda of electron. They are saying this, hai na? I mean, I don't mean to write down implies over here. So lambda of photon can be written as hc by E, and this is equals to h divided by under root of 2mk. So h can be cancelled out, and I wanted to find out E, so that's it. E will be equals to c under root 2mk, or under root 2m k into c square. So 2m k into c square, that means option B, easy problem. B option is absolutely correct. Please see. Acha, please note one thing. That when you are going to have an electron, use de Broglie wavelength formula like this, right? This is nothing but h divided by momentum. De Broglie wavelength. When you are going to have photon, use this formula. Don't try to write down de Broglie wavelength for a photon. Okay? It doesn't have any mass. Then write hc by lambda. Then obviously you can relate it. You have got this question in NEET 2025 also. Moving on, time poll is done. Neutron decay. Neutron decay in free space is given as follows. Parenthesis basically means what is inside in this bracket. Okay? Remember, this is an electron. This is an electron. If you have an electron, my dear friends, you will require one more particle, right? The reason for that particle we have not studied it, right? Reason for that particle we have not studied it, but please remember this particle is anti-neutrino. This particle is anti-neutrino. This particle is anti-neutrino. C. This particle is anti-neutrino. Clear? Very good. If the radius of a nucleus, if the radius of a nucleus of mass number 3 is R, then the radius of the nucleus of mass number 81 will be. Quick, find the answer. If the radius of a nucleus of mass number 3 is R, then the radius of nucleus of mass number 81 will be. No. Some of the questions are from, only 1 or 2 questions are, this question is not from mission 30. No, bache. This is not from mission 30. Earlier questions were also not from mission 30. 1 or 2 questions might be common, but 90% of questions are new. If the radius, okay my dear friends, everyone should remember that radius can be written as some constant value a times, or let me write it as r naught times a raised to the power 1 by 3. 1 by 3, right? So mass number, so this is r, that's it. So this is going to be 3. So radius r dash will be r naught, and this is 81 whole raised to the power 3. So let's take the ratio. Let's say this is r, this is r naught, and this is 3, right? So this will become, this is 9 times 3, that is 27. So r dash will become r times 3. So 3r is the correct answer. 3r is the correct answer. Option A. Option A. Clear? 3r is the correct answer. Done. Sorted, my dear friends. Moving on to the next one. Achha, this question is from mission 30, right? This question is from mission 30, but these are common problems. If an electron hydrogen atom jumps from 3rd orbit to 2nd orbit, got it? 3rd orbit to 2nd orbit basically means, my dear friends, that this is 2nd orbit basically means Balmer series. And what I have said to you, by the way, I'll open the poll. I'll open the poll. Balmer series, and it is coming nearest. Huh? Nearest basically means that energy is minimum. That means lambda will be maximum. This is also maximum wavelength. This is also maximum wavelength. So 1 upon lambda will be equals to R final is 2, that is 4, minus initial is 3, that is 9, square of 3 times 9 times 9 times 4 times 4. So lambda will be 36 divided by 5R. 36 divided by 5R. 36 divided by 5R, and right now they are also talking about frequency. So no problem here if they are talking about frequency. Please remember V is equals to F lambda, right? So this will be equals to C divided by lambda. So C and lambda was, this is 5R, 1 upon lambda is 5R by 36. So 5 RC divided by 36. 5 RC by 36, option B. And by the way, please remember this is going to be the longest wavelength. Longest wavelength, nearest. Shortest wavelength from infinity. Got it? Done? Clear, bachche? So correct answer is option B. Correct option is option B. Radioactive radiation in order of increasing penetrating power. Increasing penetrating power. Time starts now. Increasing penetrating power. What increases the penetrating power? Well, if the particle has mass, it has got charge, so it will interact with other particles, right? For example, as alpha particle is very bulky, so it will interact, so it will have less penetrating power. Then comes beta, and then comes gamma. Gamma is massless, and it has got very high, it travels with speed of light, so very high energy. So this has got very high penetrating power. It requires lots of lead bricks to stop gamma particles, right? And then comes beta, then comes alpha. So alpha, beta, gamma, that means option C is correct. Option C is correct. Clear? Clear, doston? Option C is absolutely correct. Done? Alright. Clear, clear, clear. Moving on. Which of the following statements from given 4 statements are correct? Starting the timer, read the statements, try to solve it under 1 minute. First, the rest mass of stable nucleus is less than the sum of the rest mass of the separated nucleons. True or not? Let me know. True or not? Let me know, my dear friends. Be quick. Quickly find out the answer. The rest mass of stable nucleus is less than the sum of the rest masses of its separated nucleons. True or not? Then next is the rest mass of stable nucleus is greater than the. This is absolutely wrong. First one is correct. Right? Rest mass, second one they are saying stable nucleus is greater than the sum of the rest masses of separated nucleons. This is not correct. In nuclear fusion, energy is released by fusing 2 nuclei of medium mass. In fusion happens when we have got light nuclei. When we have got light nuclei. So this is also incorrect. This is also incorrect. And this is also incorrect. Write down in the chat box if you guys are following what I have said. Be quick, right? You want to select the correct one only. In nuclear fission, energy is released by fragmentation of a very heavy nucleus. Fission is absolutely correct. So, option should be A and D. A and D. A and D. That means C option. Good. Very, very good. Clear? Any doubt, my dear friends? Sorted? Duration till we'll complete at least 50 more questions. 50, not 50, at least 30 more questions. Then, right? Alright. Chalo. Acha, I've got one question related with nuclei, alright, related with nuclei. Two lighter nuclei, each of mass A equals to 15, fuse together to form a single stable nucleus of mass number 30. The binding energy per nucleon of the lighter nuclei is 5.4. Let's solve this question. You have got, question basically says that you have got two lighter nuclei, right? So, two lighter nuclei, X plus X, and we are getting a heavier nuclei, and the mass number is 15, mass number is 15, and mass number of this is 30. This is, let's say this is a reaction, right? And now they are saying that binding energy per nucleon of lighter nuclei is 5.4 mega electron volt, while that of fused heavier nuclei is 6.8 mega electron volt. Got it? Done. So, if you want to find out the total energy released, what you are going to do is binding energy, total energy 30 multiplied by 6.8 mega electron volt minus 15, that is 30, multiplied by binding energy per nucleon, that's 5.4. This means that 30 multiplied by 6.8 minus 5.4. So this will come out as 30 multiplied by 1.4. Point gets cancels out. This will come out as 42 mega electron volt. 42 mega electron volt is the correct answer. C is the correct answer. Alright, C is the correct answer. Clear? Any more doubt? Quickly let me know in the chat box, doston. Be quick. Consider the following nuclear decay. Uranium-236 is at rest. Chalo, let's start. If the uranium nucleus is at rest before its decay, please note that it is at rest before its decay. Which of the following statement is true concerning the final nuclei starting the pole? They have equal kinetic energies, but the thorium nucleus has much more momentum. Second, they have equal kinetic energies and momenta of equal magnitudes. That means second option saying momentum and kinetic energy both are equal. They have momenta of equal magnitudes, but thorium nucleus has much more kinetic energy. Last option, they have momentum of equal magnitudes, but X has much more kinetic energy. Nice problem. Nice problem. Let's suppose this is thorium. Sorry, let's suppose this is uranium. Uranium was at rest. Then it decayed, and you have got thorium and you have got X. By the way, thorium is too heavy, huh? Thorium is too heavy. And can you please tell me what is X? X is helium. X is helium. Okay? X is helium, by the way, huh? Helium, obviously it's going to be way lighter. So this will be 2 and this will be 4. Now my point is, dekho, initially it was at rest. That means initial momentum was 0. Initial momentum of system was 0. This means that finally momentum should also be 0 of entire system. This is because of conservation of linear momentum. Decay is also happening because of internal reasons, right? Got it? This is not from test series, bachche. Got it? Now the point is, bachche, that momentum are same, which means that mass of thorium multiplied by velocity of thorium is equals to mass of X multiplied by velocity of X. I think in the mocks PW test series, I remember, in that they have given it as helium. Now I remember. But this is different. Question is different, right? So now we know that mass of thorium is definitely greater than mass of X. This is far more greater. So that means velocity of X will be far more greater than velocity of thorium, right? And we know how to write down the kinetic energy. Kinetic energy is written as 1/2 mass and square of velocity. Now this basically means that Vx will be far more greater than Vt because you are squaring it. Got it? So that means option D is absolutely correct. They will have same momentum, but kinetic energy of lighter nuclei will be more than the heavier nuclei. Will you remember it? I am going to summarize it for you. Decay is happening, initially it was at rest, so final momentum should also be 0. That means the magnitude of momentum of thorium or both the daughter nuclei must be same. That means if momentum are same, that means we can easily find out the ratio of velocity. Ratio of velocity will be mt divided by mx. This is far more greater than 1, not far more but greater than 1. So this is also greater than 1. That is Vx is greater than Vt. Got it? Moving on. Next question. Done. You need to find out current through the resistance 1 kilo ohm in the circuit given in the figure. Let's start. Let's start. Be quick. Come on. You need to find out the current flowing in the circuit. Good. Very good. First of all, this is reverse bias, huh? This is N type, this is P type. So this is reverse bias. Reverse bias. This is forward bias. Correct? So we can remove this entire branch. Because it is reverse bias, it will behave as an open circuit. Now you have got 1 kilo ohm, 500 and 500. That means R equivalent will become 1 kilo ohm plus 1 kilo ohm. 500 plus 500, 1 kilo ohm. That means 2 into 10 to the power 3 ohm. Is that correct? Yes. 2 into 10 to the power 3, that means 2000 ohm. So current will be voltage divided by resistance, that is 2 into 10 to the power minus 3, that means 5 milliampere. 10 to the power minus 3 is milli, so milliampere, 5 milliampere. B option is the correct one. B option is the correct one. Alright, clear? Any doubt, doston? Moving on to the next one from semiconductor, right? A pure silicon Ni, this is intrinsic density, this is charge concentration, intrinsic charge concentration, it is 10 to the power 16 per meter cube, crystal at 300 Kelvin, 10 to the power 21 atoms of phosphorus. Phosphorus basically means group 15 are added per cubic meter. The new hole concentration will become, sorry, correct answer for the last one was B. Very good. Moving on to the next one, I have read it for you, starting the timer. You have to use mass action law in this one, very, very important. Mass action law for semiconductors. Mass action law. This is Ne times Nh is equals to Ni square. Phosphorus whole concentration, that means we are talking about P type, sorry. So now they have said doston, they have given us Ni, ठीक है, they have given us Ni, so Nh will be square of Ni, that means 10 to the power 16 whole raised to the power 2 divided by Ne. Ne is 10 to the power 21. नहीं N type ही है तो course. So this will become 10 to the power 32 divided by 10 to the power 21. That means minus 21, which will be 10 to the power, this will become 111. So 10 to the power 11 per meter cube. 10 to the power 11 per meter cube. This is meter cube. C is the correct answer. C is the correct answer, dosto. Good. C is the correct answer. Done. Any doubt? My dear friends, be quick. Let me know in the chat box. Quick. Very important, very easy. Do remember mass action law. All right. Done. Clear? Moving on to the next one. Logic gates. I'll also explain logic gates to you. The diagram of the logic gate is given below. Acha, let's solve it after some time. Let's start with some easier questions. Let's start with some easier questions of logic. ठीक है? Like for example is this one. Acha, हाँ, now you can say that this one is from mission 30. I have chosen this for your practice. ठीक है? Let's take it as a practice. Then I'll give you my question also. I'll give you this question also. Don't worry. But let's start from here. For the digital logic gate, you have to find out the Boolean expression for the final output of Y. Start, time, and now I am helping you guys. This is A. This is also A. This is B. Acha, this is NOR gate, huh? This is NOR gate. NOR gate. That means the output will be, my dear friends, A plus A and a bar on it. Please remember, I am going to explain some properties over here. A plus A is A. A plus A is A. So this will become A plus A is A and A bar. And then, so finally you have got on this part, you have got B, on this you have got A bar. Now again, or that means A bar plus B and a bar. So finally, dosto, finally the answer is Y equals to A bar plus B and bar. Now what I have said, always break this line and change the sign. So you are going to break the line and distribute it like this and change the sign. Now next property that we are going to use over here, I am explaining Boolean algebra also. A complement and complement becomes A. That means A bar bar becomes A. So this becomes A dot B bar. So A dot B bar. A dot B bar, option A is correct. Option A is correct. Up see, this is, you guys were saying that this is from that, still only 69% of you could do this. Fine, chalo, let's solve more questions like this. This is our next problem. The diagram of a logic is given below. Okay, and you have to find out the output of the circuit is represented by, let's start. I'll give you 90 seconds. Solve this with me. Solve this with me, my dear friends. This is W, this is X, this is OR gate. OR gate basically means W plus X. W plus X. This is W plus Y. This is W plus Y. This is OR, and this is AND. Let me write it also for you. This gate is OR, this gate is OR, and this gate is AND. And finally output will be W plus X dot W plus Y. Something like this, right? Now when you are going to multiply these two, you will get W dot W plus W dot Y plus W dot X. Matlab X times W, you can write it as W times X also, plus X times Y. X times Y. Dosto, this thing is nothing but W. This is nothing but W plus now you can write this thing down as W, and this will become X plus Y. plus xy. Kindly see here now. Kindly see here now. From this I am taking w as common. So I will get 1 plus x plus y. Doston, if you are going to add 1 with any logic, answer will be 1. Because 1 plus 0 is 1. Kindly see here if any student has doubt. 1 plus 0 is 1. 1 plus 1 is 1. So it doesn't really matter what this is. So it doesn't really matter what x plus y is. 1 plus x plus y will be 1. Got it? 1 plus x plus y will be 1 plus xy. So now solving this, 1 plus this will become simply w plus xy. W plus xy, w plus xy, w plus xy, D is the correct answer. Clear? Clear doston? Quickly write down in the chat box. If you have any doubt, do let me know. I'll explain it again. Please remember 1 plus x plus y I have written. 1 plus x plus y I have written as 1. Done. Done, 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 done. 1 plus 1 is equals to 2 not, sir. 1 plus 1 is equals to 2. Yes. Sorry, my mistake. Clear? Done. Mini cart. I know your doubt, bacha. I know your doubt. Your next doubt is, sir, 1 plus 1 is 2 and 2 plus 2 is 4. Moving on to the next question. So, correct answer is option D. Very, very good. Very nice. This is also done. Moving on. Now, let's move on to the next question. Next question, my dear friends. A very, very nice problem. A very, very nice problem from logic gates. Let's start this. 90 seconds. I'll give you 90 seconds or I'll give you 120 seconds. Let's start. 120 seconds and I'll do this with you. So don't worry. I'll also do this with you. Don't you worry. This is A. So A, B. This is AND. So this becomes A dot B. This is A naught. This is inverter. So this is A naught. This is B naught. Arey yaar. Sorry. This is A naught. This is B naught. Now this is AND. AND basically means A bar dot B bar. And now finally you have got Y equals to A dot B plus A bar dot B bar. This is OR, but you have got an inverter, that means NOR. Clear? Sorted, my dear friends? Clear, right? Now remember, break the line, change the sign. What is my tip? Break the line, change the sign and distribute the line also. So breaking the line means A dot B, break it, distribute it and change the sign. Something like this. Now this will become A bar plus B bar dot, this will become A bar plus B bar. Clear? Clear? A bar B bar is A and B. So you will get A bar plus B bar dot A plus B. Now you will get A into A bar plus A bar into B plus B bar into A plus B bar into B. A bar into A 0, B bar into B 0. My dear friends, please see another rule for you. A dot A bar is always 0. Why? Because if let's suppose A is 1, this will become 0. 1 dot 0 is 0. If let's suppose this is 0, this will become 1, this will become 0. Got it? So A into A bar is 0, B into B bar is 0. You are getting, finally you are getting those. Finally your answer is Y equals to A bar B plus B bar A, and this is actually XOR gate. This is XOR gate. Sorry. This is XOR gate. D is the correct answer. D is the correct answer. Good, very, very good. Clear? Any doubt, my dear friends? Quickly write down in the chat box. Please remember what XOR is. Right? Please remember what XOR is. I am going to draw a table for you for XOR. Let's suppose this is A, this is B, this is A, this is B, right? Acha, theek hai, why to draw table? But if you will ask me, I'll simply say, understand one thing. The answer will be 0 if both of them are identical, and answer will be 1 when both of them are different. This is XOR gate. Theek hai, you can draw the truth table by yourself. I don't have to draw. Clear, my dear friends? Quickly write down in the chat box if explanation is all sorted. Moving on to the next question. This question is not from your PW mock test, hai na? I have taken some questions, but that was for your practice. Chalo, let's move on to the next question. Assuming the diodes are ideal, current through the battery is 0. You have to select the answer. You have to select the answer. 60 seconds. You have to select the answer. Come on. Be quick. Come on. Current through the battery is 0. So first of all, this is forward bias. This is forward bias. So current will flow. It will not be 0. This is forward bias. This is reverse bias. So in this current will be 0. No current will flow. They want us to find out when, in which case the current through the battery is 0. In this one, this is reverse bias, this is forward bias, but current will flow because it will flow from this path. So this is also not the case. That means the answer is in second only. In second only. That means C option is correct. C option is correct. Clear? All right. Done. Moving on to the next one. Clear, my dear friends? Quickly write down in the chat box. Be quick. Acha, this is a nice question from Mission 30. So you guys can solve this. This is a nice problem. Not I mean suitable for 2 stars, 4 stars, but fine. A new type of a problem. Let's start. 90 seconds. Let's begin. See what they are saying. They are saying match the target logic gates to be realized in list 1 with the minimum number of universal gates required to construct them, right? They are saying NOT gate using NAND gates. NOT gate using NAND gates. Clear? How many NOT gates are required? Sorry, how many NAND gates are required to make NOT gate? So only one. It's simple, my dear friends. Please understand. NOT gate basically means that if you have got A as input, the output will be A bar. So in NAND gate दोस्तों, if let's suppose both of the inputs are A, then answer will be A dot A and bar. A dot A and bar. So that means A dot A is A and A bar, so only one is needed. So answer for A is going to be 1. That means third. AND gate using NAND gate. दोस्तों AND gate basically means when something like this happens. That means A dot B. Now you need A dot B. So how to get A dot B, right? So if let's suppose you have got A and B, but you must use NAND. So this will become A dot B and a bar on it. A dot B and a bar on it, right? And then again you have got one more NAND gate, correct? No, this will not work. Will this work? No. So let's do one thing. You know what we are going to do in this is, we are going to take two outputs from it and we are going to give it to same NAND gate. So this will be A dot B bar and A dot B bar. So that means finally output is going to be A dot B bar dot A dot B bar and a bar on it because this is NAND. Again you are going to do the same thing. This is, let's suppose, some X, this is X. X dot X will be X. So that means this will be A dot B bar and a bar on it. That means A dot B. So you will be required 1 and 2 NAND gates. So this is 2 NAND gates. That means the third one will be 3. So for first matches to third, A matches to 3 and B matches to 2. B matches to 2 and C matches to 1. That means option A. Option A. That means A is correct. Good. Very good. Done. Clear? Any more doubt in this one, my dear friends? Moving on to the next one. Moving on to the next one. A question from Screw Gauge. Explain the B part again. Fine. I'll explain the B part again. Veeramani. No problem. For the B part, what I have done is, for the B part, this is A and B. So this is A dot B. Now I have taken another input from it. I can do this. This is known as twisted inputs, right? So I have taken another input from it and I have used a NAND gate, another NAND gate, and the output from this first gate is being used in second. So one input is A dot B bar, another is also A dot B bar. So this will become A dot B bar dot A dot B bar and a bar on it, because basically what does an AND gate does? X dot Y, because we have used Y, so P dot Q, and what does NAND do? P dot Q divided P dot Q and a bar on it, right? And now if you're going to break this line, it will get distributed. By the way, don't break it. Simply say, sir, this is P and this is also P. So P dot P is P. So P bar and bar. So that's A dot B. Veeramani, hopefully your doubt is cleared now. Done. Now let's solve some questions from Screw Gauge. Clear? Question, your doubt is sorted. The diameter of a cylinder is measured using a vernier caliper where 10 vernier scale divisions coincide with. Chalo, this is for your practice. Let's start. 90 seconds. I'm going to help you. They are saying that 10 VSD, my dear friends, 10 VSD coincide with 9 MSD. 10 VSD coincide with 9 MSD. Quickly we can write down, that means 1 VSD is 9 by 10 MSD. From this I can find out least count. So least count will be, obviously we know 1 MSD minus 1 VSD, which means that 1 minus 9 by 10 multiplied by MSD, or 1 by 10 multiplied by MSD. And by the way, what is 1 MSD? One main scale division is 0.1 centimeter. 0.1 centimeter. So least count will come out to be 0.01 centimeter. Least count will come out to be 0.01 centimeter. Next is they are saying the zero error is minus 0.3. By the way, this is negative zero error. Mind you, this is negative zero error. Negative zero error. While measuring the diameter of the cylinder, the main scale reading, please note the main scale reading, that means finally the reading is 3.2 centimeter. So main scale reading is 3.2 centimeter plus fourth vernier division, that means 4 multiplied by least count is 0.01 and error is always subtracted. That means minus of minus 0.03. Please remember, error is always subtracted. So we are going to get 3.2 centimeter plus 0.04 centimeter plus 0.03 centimeter. That means finally you will get 3.2 and this will become 7. So 3.27 centimeter. 3.27 centimeter, that means option number B. 3.27, that means option number B. एक second, just a second. What has happened, दोस्तों? Hopefully everything is correct here. 3.2. Please let me know why you all have selected 3.24. This is 3.2, huh? And error will always be subtracted. This is 4. So 0.04, this will be 0.07. So 3.20 plus 0.07, 3.27. This is the first question that you have done wrong in this entire lecture. Option B is correct. If you have any doubt, do let me know. Now I am going to give you one more question for practice. You solve it by yourself. Quick. But this question is from screw gauge. Pitch is given. Pitch of 1 watt. This is 1 millimeter. This is 1 millimeter. This is 1 millimeter and 100 divisions on its circular scale. When nothing is placed between its jaws, the zero of the scale lies 4 division. That means it has got a positive zero error. This screw gauge has positive zero error. This has positive zero error below the reference line, right? Got it? When a wire is measured, the main scale reads 2 millimeter. All right, so finally the reading is the main scale reads 2 millimeter plus 45th division on, so 45th multiplied by least count and then minus positive zero error. Minus, I am simply going to write down error over here. And by the way, if you want me to write down what that error is, I can write down because that's 4. So 4 multiplied by least count. So the answer will be 2 millimeter plus least count 45 minus 4. So you just have to find out the least count value, right? You just have to find out the least count value. 45 seconds. Let's start. Be quick. And remember, the formula for least count is pitch divided by total number of circular divisions. So pitch is 1 millimeter and total number of circular divisions are 100. So answer will be 0.01 millimeter. 0.01 millimeter. That means 2 millimeter plus least count is 0.01 millimeter and this is 41. So finally answer is going to be 2 and this is 0.41, right? So 2.41 millimeter is the answer. 2.41 millimeter is the answer. That is option number D. Good, very nice. Is it clear? My dear friends, quickly write down in the chat box. Sorted? Done? Any doubt? Good, very good. So almost class 12th part 2 is completed, right? YDSE, modern physics, wave optics, only geometrical optics is still remaining. So we are going to do it, but don't worry. Next, one more question, just one more question on screw gauge. Screw gauge gives total reading. Time is off, yeah. A screw gauge gives total reading of 5.12 millimeters. So this is the final reading. The final reading is 5.12 millimeter. Okay. And then they are saying the circular scale has 50 divisions, pitch is 0.55, main scale reading is 5, and you need to find out the circular scale division. 45 seconds, let's start. This will be equals to main scale reading, that is 5, plus circular scale division multiplied by least count, and then they are saying there is no error, right? There is no error, so that's it. That's it, my dear friends. Next is going to be to find out the least count. So least count will be again pitch divided by total number of circular divisions. So pitch is going to be 0.5 mm and this is 50. Doston, this will become 0.0 and this will become 1. So 0.01 mm. Now let's substitute it. If you are going to substitute it, you will get 5.12 minus 5, you will get 0.12 mm. 0.12 mm is equals to circular scale division multiplied by 0.01 mm. Both unit and decimals are going to cancel out. Circular scale division will come out as 12th. 12th man. B. Wow, good. Clear? Done? Ankita, any doubt? Henry? Neha? Everything's clear? Moving on to the next question. Some questions from current electricity. Alright, do remember we are completing the most repeated concepts in this class. Most repeated concepts. The resistivity of a semiconductor decreases with increase in temperature. This is your first statement in a conducting solid and Z. So you need to find out the answer in 45 seconds. The resistivity of the semiconductor decreases with increase in temperature. Well, why seems to make sense, right? This is true. This is true. In a conducting solid, the rate of collision between free electrons and ions increases with increase in temperature. This is also true. And that's why in the case for conductors, resistivity does increases. Both Y and Z are true. Both Y and Z are true. Good. Option C. Very, very good. Nice. Moving on to the next question. Let's solve this. In a wire of cross section radius R, free electrons travels with drift velocity V when a current I flows through the wire. What is the current in another wire of half the radius and same material when the drift velocity is 2V? 60 seconds, let's start. Concept is going to be, my dear friends, they are talking about wire of cross section, drift velocity and current. So use the formula current is equals to NEAVD. This should be your go-to formula for this question. Alright, this should be your go-to formula for this question, my dear friends. Alright. So now they are saying first radius was R, free electrons are traveling with drift velocity V when a current I is flowing, right? what is the current in another wire? Now please see. So current is I, N, let's suppose N is there. N depends upon the wire, N depends upon the wire. N is the number of electrons per meter cube. That is free electrons density. And then area is pi r square multiplied by V. That's the case. And then they are saying what is the current in another wire? What is the current in another wire? So N will be same because they are saying another wire of same material. Same material means same N. Same material means same N. And then they are saying E will remain same, and then they are talking about half the radius. So pi into r square by 4. And drift velocity is 2v. So this will become 2, and this NE pi r square V is nothing but I, so answer will be I by 2. Answer will be I by 2. I by 2 is option C. Correct? My dear friends, why D here? Why D bhai? Drift velocity is also becoming twice. Drift velocity is also becoming twice. Henry, you are constantly saying D, dost. Any doubt, bache? What is the current in the another wire if of half the radius? So radius has become half, so it becomes r by 2. So r square by 4, right? And drift velocity is 2v, so this is 2v. Clear? Done. C is correct. Mahira, is there a lag? Bhai, constantly you are giving wrong answers here. Got it? Please see. Quick. Any doubt? No, D nahi hoga. C is correct. I have solved it. It's in front of you, right? Don't use any other method of don't use method of that drift velocity, that E tau by m. Don't use all of those things. Okay? C is C. Myra ji, aise hoga C. That's how it's going to be. Current is NEAVD. A is pi r square, and that's how it's going to be, right? You need to find out current. Let's say it is I dash. This is pi r square by 4. I have solved it. You can check. I'm moving on to the next question right now. Okay, let me give you one more problem. Now they are saying if the same current flows, let's solve this. Quickly, solve this question. Don't make any mistake. Now they are saying a current I flows through a uniform wire of diameter D when the mean electron drift velocity is V. The same current will flow through the wire of diameter D by 2 made up of same material if the mean drift velocity of the electron is. You have to find out the mean drift velocity for the second one. Main concept is whenever they are going to talk about current, use the formula current is equals to NEAVD. That means now you are going to write down drift velocity as current divided by NEA. That's it. Clear? So the first they are saying, let's suppose first diameter was D, radius is R. Okay? Diameter is D, radius is R. Diameter was D, so radius will be D by 2. Clear? Now if diameter is D by 2, radius will become D by 2 and half of that, that means D by 4. Got it? D by 4. So basically if you are going to actually compare, it's nothing but it's half of R. Don't worry about diameter. It's half of initial radius. Got it? Now they are saying, doston, they are saying drift velocity is V, current is I, and NE, and this is going to be pi into R square. Sorted? Now V dash, if current is same, and NE pi, and this will become R square and by 4. Got it? Because this is R by 2. So this will become 4 times of I divided by NE pi R square. So that's 4 times of V. So 4 times of V, that means option D is correct. Clear? Got it? Any doubt? Quickly write down in the chat box, my dear friends. Done? D is absolutely correct. Very good. Henry, Mahira, Robin, any more doubts in this question? Sure. Good. Very good. Clear? Great. All right. Next question. Current density in a cylindrical wire is given by this. The current flowing in the wire is. This is the next question. Let me explain this question to you. See, the question is basically, obviously, we talk about cylindrical wires, right? We always talk about cylindrical wires and they are going to look something like this. Correct? But right now I'll be more interested in the cross section diagram. So let's draw cross section diagram something like this. And then what's happening over here is this complete radius is from center to here, it's obviously radius is capital R. Radius is capital R. But for R by 2, density is different. For R by 2, density is different. For this, current density is different, and for the rest of the part, current density is different. Got it? So please pay attention. Question is nice. Let's suppose if it was of same current density, then I would have said that current will be equals to current density multiplied by simply area. Right? Current density multiplied by simply area. This is what I would have said. The next point is current density is also non-uniform. It is non-uniform. Can you please see, this is non-uniform. This is also non-uniform. That means you will have to integrate it. Clear? So what you need to do is, you need to actually solve it something like this. Let's suppose from center you are going at a distance of x. From center, my dear friends, pay attention and try to solve it. From center you are going at a distance of x and you are making a ring. You are making a ring of infinitely small width dx. So this is dx. This is dx. Right? If you are going to open this disk over here, it will look something like this. So this is infinitely small width and this is going to be 2 pi into x. So its small area will be 2 pi x into dx. It's a nice problem, my dear friends, right? It's a nice problem. Pay attention. So if you want to find out the current in this, so that will be small current di and that will be current density dot area, and instead of area I am going to write dA. Got it? And let's integrate it. So first integrate it from 0 to r by 2 and then integrate it from r by 2 to r. So when you are going to put 0 to r by 2, use this current density, and when you are going to put from R by 2 to R, use this current density. I am going to write it down for you, don't worry. So this will become J naught x by R minus 1 multiplied by dA, and dA is 2 pi x into dx from 0 to R by 2, and plus integration from R by 2 to R, and this will become, my dear friends, J naught x by R dot dA, that is 2 pi x into dx, and then integrate it and then enjoy. Clear? First, quickly write down in the chat box if this thing is clear. Find out the answer after this. Integrate and find out the answer. Duration, yeah, it's a good question. Absolutely. Integrate this, multiply this x with this. This will become x square by r. This will become minus x. 2 pi and j naught are constant, so we don't have to worry about that. X square integration will become x cube by 3. X integration will become minus x square by 2. Clear? You are getting the answer? Fine. Okay. If you are saying answer D is correct, so D is correct. The rest of the students' answer should be in the comment section. Right? Chalo. Now let's solve this question. Find the potential of point 0. Ankita, bas, that's all. This is going to be one of the last question. Then we are going to end our lecture. Right? One of the last question. I'll see if any questions are remaining, else we'll end. Let's first check this problem. Okay. Find out the potential of point X, 90 seconds. The trick is, in these types of questions, always imagine that current is flowing outwards. Always imagine that current is flowing outwards. That means, let's say this is I1, I2, I3 and I4. Assume something like this. Again, let me tell you, I1, I2, I3 and I4. This is our assumption. It could be wrong, but we can use it to solve our question. Now, we are going to actually use the concept of KCL, Kirchhoff's current law. According to KCL, we can say that the sum of outgoing current. What is outgoing current? You are going to say, sir, all currents are outgoing. That means I1 plus I2 plus I3 plus I4, all are outgoing. This should be equals to sum of incoming. Well, nothing is incoming, so that means 0. Now, this is our assumption. We can use it to solve our question. If any of our assumption is wrong, we are going to get a negative sign in front of the magnitude of current. That's all, right? But you can definitely use something like this. So, no worries. Next is, my dear friends, current can be written as, any current can be written as potential difference divided by resistance. So, when you are going to move from point X, let's assume the potential of point X to be X. So, always current flows from higher potential to lower potential. So, please note how I'm going to write it down. X, now can you see a positive terminal of a battery? Then minus. So, that means I'm going to write down X minus 20 because there is a potential drop, and then finally potential is 10 divided by resistance is 1. I don't have this much space, so I'll be considerate. X minus 20 minus 10 divided by 1 plus, for I2, my dear friends, we'll start from X and then again positive terminal, and we are exiting from negative. So, minus 15 minus 20 divided by 2 plus X minus 5 minus of minus 50. So, plus 50 divided by 2 plus X minus of minus 30 divided by 1 is equals to 0. Solve. You can now find out the value of X. I can see we have got 2 over here, but first I'll simplify it. I'll get X minus 30 divided by 1 plus X minus 25 divided by 2 plus X minus 45 divided by 2 plus X plus 30 divided by 1 is equals to 0. Now to get rid of this 2, what I can do is I can multiply 2 over here, I can multiply 2 over here, and then finally I'll get, chalo, now you guys can solve this. This will become 2x minus 60 plus x minus 25 plus x minus 45 plus 2x plus 60 is equals to 0. 60 and this gets cancels out. My dear friends, 2x and 2x is 4x and this is 6x. So this is 6x and then 5, this is 10, this is 70. So this is minus 70 is equals to 0. So x will be 70 divided by 6. Please check here. I mean, hopefully, is there any mistake? Kindly check. Doston, quickly. Hopefully, this is x 20 and this is minus 30. So 20x minus 30, this is absolutely correct. Divided by 1, this is correct. X minus 5 minus 55. So that was wrong here. And that's absolutely correct. X minus 5 and plus 50. That's absolutely correct. No problem. No problem. Check bhai, what is the correct answer? Concept is absolutely correct. Tell me the correct answer. According to me, answer this was coming out to be 35 by 3. 35 by 3. 35 by 3 and we are not matching. Let's see. Be quick. Tell me the answer. Come on. 5 by 3, are you sure? So that's becoming 35. Kya kahin pe? हाँ, this was the mistake. This is 35. This is the mistake, doston. This is 35. This was the mistake. Okay, now got it. Now got it. So, acha, theek hai, we don't have to. This is 35. This is 35. Okay. So 6x was absolutely fine, and this came out to be 70 and 80. 80. So x is equals to 80. This is coming out to be, my dear friends, this was the mistake. We found our mistake. I have, by mistake, I have written it as minus 15 and minus 20. So this will become minus 35. So this will be minus 35. No other mistake than this. Answer is minus 5 by 3. X is minus 5 by 3, not 10 by 3. X is coming out to be minus 5 by 3. Minus 5 by 3 volt. Correct answer is C. Check. C is correct. And let me know in the, well, most of you have said B, but no, answer is C. Answer is C, dosto. Check once again. Answer is C, bhai. It's negative. It's coming out as negative. It's coming out as negative. Once check. I believe it is negative. In my answer key, it is negative. Minus 5 by 3. Okay. Clear? Done? Any doubt? Do let me know in this question if you have any doubt. Other than most of the questions we have already solved. Let's look at one or two more questions. A piece of copper and another germanium. Copper is a metal. Copper is a metal. Germanium is a semiconductor. Are cooled down. That means temperature is decreasing. This means that temperature is decreasing. If temperature is decreasing, that means alpha of semiconductor is negative and alpha of conductor is positive. So if temperature decreases, semiconductor's resistance will increase, right? So resistance of copper decreases and germanium increases. D should be the correct answer. Correct? D should be the correct answer. Clear? D should be the correct answer. Alpha for semiconductor is negative. That means with decrease in temperature, resistance will increase. Whatever happens, it will be reversed with resistance. And this same thing will happen over here. If temperature decreases, resistance decreases. It is positive. Clear, my dear friends? Any more doubt? So we have talked about, acha, let's solve this question also. Let's solve this question also, my dear friends. And take some time. A photodiode is preferably operated under reverse bias condition for detecting optical signals. Photodiode is preferably under reverse bias. This statement sounds correct, right? It sounds correct. First is correct. Second is a solar cell must be connected to an external forward bias. This is absolutely wrong. Solar cell, we use solar cell to get power, to get energy, right? We don't have to provide any external bias to it. So this is incorrect. This is absolutely incorrect. So statement 1 is correct, 2 is incorrect. B option is going to be the correct answer. All right. Let me know, my dear friends. Done? Any more doubts? Sir, previous question x plus, let me check here. Let me check. Thank you so much. If there is any mistake, I'll check definitely. Previous x plus 45. है ना? You are saying x plus 45. 45 where it at this point. This is why. This is the point. Thank you so much. Another mistake. Thank you so much. This is going to be x plus 45. Certainly, bachche. So this is going to become plus. This is going to become plus. That's why answer, we were not getting our answer. So now this will become 6x and this is plus 45. So this will become plus 10 equals to 0 and x will be equals to minus 5 by 3. Thank you so much. What's your name, dost? I'll explain. What's your name, bachche? Please explain the previous question. Which previous question, Mahira? In a matter of 5 or 10 minutes, we are solving so much of questions. Which previous question? This one? This one? Correct answer is minus 5 by 3. Now we have got it. This was also plus 45. There were 2 mistakes in this. Done? Which question, Mahira? Ask. Write down the topic name, so I'll open that question. Sir, this one only. In this question, I have only used Kirchhoff's current law. I have said that let's assume that current is only outgoing from this point, from this junction. I1, I2, I3, I4. That's it, right? And then I have simply used I have simply used Ohm's law. Current is equals to voltage potential difference divided by resistance. Right? Potential difference. So from here, if you are going to go in this direction, x minus 20 minus 10, x minus 15 minus 20, x minus 5 and minus of minus 50. So x minus 5 minus of minus 50 becomes plus 50. X, there is no battery, so x minus of minus 30, so becomes plus 30. Got it? And divided by resistance. Then I have multiplied 2 in the denominators of first and last term to make common denominator and then simply solved it. Minus 5 by 3. So, Mahira, this is your question. Got it? Now any doubt? Clear? Sorted now? Quickly let me know in the chat box. 1 or 2 more questions, dosto. Mahira, hopefully now everything's clear. What happens to the mass number and atomic number? 60 seconds. Start. What happens to the mass number and atomic number of an element when emits gamma radiation? When emits gamma radiation, dosto. When emits gamma radiation. So in gamma radiation, basically what happens? Then excited nucleus basically transition back to, it actually not transition back, but it becomes stable nucleus, or we can say that it comes in ground state, right? So nothing changes, mass numbers and atomic number remain unchanged. A option, right? A option is correct. Clear? Very good. Last question. I think we have solved all questions of today's class. Consider the following statements regarding the physical properties of the atomic nucleus. Chalo. Solve this under 60 seconds, everyone. Then I'll show you the board, leadership board. Okay. Come on. The ratio of nuclear radii of two nuclei with mass number. Well, nuclear radii, right? So nuclear radii R depends upon A raised to the power 1 by 3. So 64 raised to the power 1 by 3 is to 27 raised to the power 1 by 3. That means this is 4 is to 3. So correct, true. Assuming the nucleus to be spherical, its volume is directly proportional to, wrong. Volume is not proportional to anything. Volume is proportional to the, its volume is directly proportional to the cube of its mass number. Acha, they are talking about volume, na? Mass number. Nahi, cube of mass number to wrong hai. Okay, just a second. Arey, what has happened, bhai? Haan. They are saying that assuming the nucleus to be spherical, volume is equals to 4 by 3 pi into r cube, right? So this, it is directly proportional to r cube, or we can say that it is directly proportional to r is a. So this is wrong. It is not directly proportional to cube of mass number. This is wrong, incorrect. The density of nuclear matter is approximately same for all nuclei and fundamentally independent. This is also true. So first and third only 1 and 3, only 1 and 3, that means option B. Very good, great everyone. Chalo, now I'll show you the leadership board. This is your leadership board. All right, Neha and Ankita, very good Ankita. Hasini, very good. Veeramani, very good. Harshit, Dipti, Tejaswini, Anu, Farzana, hi Farzana. Yash, hi Yash. Sejal, Mahira, Saharika, Meena, Amit, Raj, Hari Prasad, and everyone. Ishani, Shobha, very good everyone. Very good dosto. Great. So now in next class we are going to continue the remaining chapters. This was about the most repeated, most important question class, right? Now in next class we are going to talk about electromagnetism and geometrical optics. That's now remaining. And from 11th portion, I believe mechanical properties of solids, fluids, thermodynamics and gravitation. So first part of class 11th is finished, second part of class 12th is finished. Now we'll focus on electromagnetism and we'll focus on the part 2 of class 11th, right? So all right, so stay tuned. Please follow this channel. On this channel you are going to constantly get all the updates of biology, of chemistry and physics. And I think in 1 or 2 days there will be one more video. It will get uploaded of top 20 most expected questions. So that will be also very important for you. ठीक है? That will be all दोस्तों. Thank you so much. Bye. Take care everyone. Any doubt from today's class? Hopefully all questions are done and dusted. There were no controversial questions, right? All right. Now I'll see you on, I think my next class will be on today's, I think next class will be on, I think Thursday, right? So we'll see you then. Thank you Myra. Thank you so much. Thank you Shobha. All right. Good night to you as well. Bye-bye. सर मत जाइए, ओके नहीं जाते, यहीं रहेंगे फिर। रॉबिन, एवरीथिंग्स गुड, यश ऑल गुड, ओके, बाय बाय एवरीवन, बाय बाय, बाय दोस्तों, सी यू इन नेक्स्ट क्लास, ऑलराइट, सी यू इन नेक्स्ट क्लास माय डियर फ्रेंड्स। चलिए बाय बाय, थैंक यू सो मच, बाय।